Hello everyone, welcome to yet another video of the series where I would be explaining lead code problems to you. So this is problem number 11, container with most water. The difficulty level of this problem is medium. So let's start reading the question first. You are given an integer array height of length n. There are n vertical lines drawn such that two endpoints of the ith line are I, 0 and I, height at I. Okay, so find two lines together with x-axis uh, form together with the x-axis form a container. So let's read this line again. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, so what this question says is we would be given an array which would be named height, and it would contain certain numbers. Okay, it would be of length n, and these numbers would be nothing but the vertical lines that can be drawn on an x-axis. Okay, so as you can see in this example, we have 1, then we have 8, we have 6, 2, and so on. So what we have to do is we have to create a container out of it, and we have to create this container in such a way that it holds maximum amount of water. Okay, and to find the maximum amount of water, what we have to do is we have to find the area of this container, and the simple formula would be to take the length and to take the distance. So in this example, the output for maximum water is 49. How did we come to this conclusion? So we had 7, we created a container out of 8 and 7, and to get this, what we did is we took 7 and we multiplied it by 7. So since 7 is here is the lower one of the two, and the distance between these two is 7. So 1, 2, 3, 4, 5, 6, and 7. So 7 sevens are 49. In this way, we came to the conclusion that we have the maximum amount of water that can be contained in this particular container, or in this particular example is 49. So let's see how we can actually solve this problem via code. So you might be wondering how we can come to a solution for this. One way of solving this is brute force, but that is not a very optimal approach. We can solve this problem by using a two-pointer method, which is very, very, very optimal, and the time complexity for that one would be O(n). So how brute force works here? We'll take two points, a start point and an end point, and we'll take another variable named water that would actually contain the maximum water that we have found till now that can be contained. Okay, now what we will do is we'll run a while loop, and in this while loop we'll check the condition if our start is less than end or not. Okay, since we are taking two points from the extreme side, our start cannot be greater than end or equal to end, because there would be at least one space for water for it to be a container. Okay, so we'll start a while loop where we'll check for this condition. Now inside this, what we will do is we need two parameters to calculate the water level, the area of water. We need the distance between 2 points, and we need the lower point. For our just take for this example, we have 8 and 7, so we needed the lower point because If we'll take 8, there would be one point where the water would flow out. So 7 is the point where it holds the water at a level. So we need the distance between 2 points, and we need to multiply it with the minimum point of the two ends of the container. So here I have, if you can see, here I have written a formula where we are taking the distance end minus start and we are multiplying it with minimum. So how we would find the minimum of the two? We'll take use this formula math.min, and inside that we'll do height at start, whatever is the height at start and whatever is the height at end. We'll take the minimum of the two, and we'll get a certain result. We'll store that in current water capacity. Okay, and then we need to check if the previous water capacity that we have, if that is great or if this one is great, which one of the two is has more water capacity. So for that, I have used the formula math.max, and I'm checking if previous stored capacity of the water is great, or if the current stored capacity of the water, if that is great. So whichever is the greater one, whichever is the maximum one, we'll store that in water. Now, how will we move the points of this um, two pointer um, approach? So here we will make sure that we always move, um, increase or decrease the point where we have the lower end. So for the first iteration, if we'll get 1 and 7, we'll increase from here. We'll increase a pointer from here. But if 1 would have been here, we would have increased the pointer from here. Now why so? The idea is that whichever side we have the pointer, the height of whichever pointer is low, it means that that pointer can contain less water. Okay, we'll always shift from that pointer with the aim that we might find um, a better heighted pointer in the next shift. Okay, so just hear me out again. We will always move our pointer or shift our pointer at the end where the height of the pointer is less, and we will do that because we would always want to find a pointer with the height that has a better height than the previous one. Okay, so here in these three statements, what I have done is I've created a if statement where I'm checking if the uh, height of the start pointer is less than end pointer or not. If it is less, then we'll shift the start pointer. If not, then we'll shift the end pointer. Okay, this while loop will keep going on, and there would be a point where we'll find the area of water where it was the maximum, and once we exit this while loop, we'll return the water. So this is the entire approach of finding container with most water. Let's run it once. Done. Thanks for watching.